when we said that, do you know the speed of light? So everyone got a value of 3 into 10 to the power 8, and some say that 2.99 into 10 to the power some. The first time when I know this value, I got a thinking that okay, this value was determined by some lavish experiment or some very big lab held at somewhere with super expensive equipments and everything. But when further I study and got to know that this was done just by pen and paper. So first other thing that I got is like, do we really made this big of achievement by using just pen and paper and using our brain? Then I thought, okay, maybe just like a sci-fi movies, we done some great calculation and find out the speed of light. But then I saw that by using some fundamental laws that we even learn in high schools, using that and just playing around those formulas, we got the speed of light. And that how we know how the speed of light changed a many fundamentals law in our whole scientific world, especially in physics. So in this video I will be deriving and explaining the speed of light, and I will try as much as it can be simpler way, cause as I said, it is used of fundamental laws. That's why. And to be surprised that the video that you will be going to see is suited way before than this intro. Well, I even edited the whole video and I forgot that I didn't even record the intro. So here I am recording the intro, and the whole video is already edited. So there may be some changes, so ignore that. Calculation of speed of light, that is C. So coming back to my screen, so I would answer your why question first. Like, why do we need to calculate it? If we have a value, we have that okay, speed of light is very high, then why do we need speed of light? So I would say it's a fundamental constant. Firstly, like if you say anything like you want to relate energy with mass, we have the famous E equals to mc square. E is particularly energy. What is m? That's a mass. What is c over here? That is speed of light. So as you can see, we have a multiple things moving around the speed of light in a very fundamental way, I would say. Like we see everything, that's an eye, and if there is some object over here, we can't see it until unless some source of light falls on it, and then we have a look over it. Then okay, we say, oh, we got information that okay, we have a object here. If there is nothing, if there is no source over here, we can't even see it, and for us it will be nothing. There will be no particle over here. So speed of light, we need to calculate it for many things, as I said before. So light for moving like to derive it, to calculate it, I would say to calculate it, firstly let me tell you about light. So actually light, we all know that light is a fundamental, like light shows duality nature. But how exactly duality nature, we will talk about in a different video. But for us in this particular video, light is an EM wave, that is electromagnetic wave. Electromagnetic wave. And that's a very simple answer to start. Like, not a simple answer, I would say, let me reframe it. That's a very simple and most fundamental assumption, I would say, to start our derivation for the light, calculate the speed of light. And its speed determines, like light speed determines us how fast EM wave interaction would be occur to any of a medium. So let me reframe it. So electron wave and its speed determine how fast interaction, how fast I will write electromagnetic wave short form EM, interaction propagates through space. So in the derivation, we will assume that the wave is traveling into vacuum, not a free space, I would say. So for the first thing, as I said, light is an EM wave. So in electrodynamics, we have 4 fundamental laws that named as Maxwell equation. And by calculating this Maxwell equation, we can actually calculate the value of speed of light. So what's all of this? The first equation goes by, that's Gauss law. What actually Maxwell did is he just recombined 4 equations and he proposes every theory about electrodynamics move according to these 4 fundamental laws, and then we got a I would say physics field of electrodynamics as well as the value of speed of light. So for Gauss law, for electricity, or I would say electrostatics, first thing, del det dot E equals to rho upon epsilon naught. We mark it equation number 1. Then we have second law, that is also a Gauss law but for magnetism, and this goes by del dot B equals to 0. And the funny part about this law is basically this law tells us that there will be no monopoles exist for any magnetic particle. Monopoles, that means if there is a north pole, there will be a south pole no matter what. Third law, that's a Faraday's law of induction. That goes by del cross E equals to minus dou B by dou T, and that's equation number 3, and that is the most important equation for this theorem. Now the fourth equation, that is Ampere's law, and I will tell you another thing about this law also, but after I write this equation. So that goes by del cross B equals to mu dot J plus mu dot epsilon naught dou E by dou T. So as we say, it's Ampere's law, so this whole thing is given by amperes, but this component is given by Maxwell. So let me reframe the name of this sentence. It's basically Ampere's law with Maxwell modification. And why actually modified is because Ampere's law is only satisfy electrostatics, when in electrodynamics, if we take curl on both sides, del cross B will be 0. That is not acceptable in physics. So he made another thing, and this is, I think, induction current, I would say. Mind me if I'm wrong. Actually, I don't remember this term, like this whole Maxwell induction term. I think induction current only. Okay, now using this 4 equation, using this 4 equation 3, 4 and 1 and 2, I will calculate the speed of light. So the actual derivation starts from here. So what we are gonna do is firstly take from equation number 3 that I said from Faraday's law, from equation number 3, that is Faraday's law. Let me rewrite it. Del cross E equals to minus dou B by dou T. Now what we are going to do is taking curl on both sides. Taking the curl on both sides. So del cross E, now del T del cross B. So what I'm gonna do is I will take first this equation and then solve it. So we have a vector identity that is explained for this term only, like del cross E can be written as del dot E minus del cross E. But in physics this thing would turns to 0. Why actually? Because this thing like del dot E is 0 in free space, and we are calculating the speed of light in free space only because firstly why, and that answer is basically speed of light in air is different, speed of light in particular medium is different, like speed of light in glass, speed of light in water, speed of light in air is every different things. But when we see speed of light, that C values 3 into 10 power 8, more specifically 2.998 into 10 power 8 is basically the value, the speed of light in vacuum. So that's why we are calculating speed of light in free space, that is vacuum only, to assume that this thing, the value of del dot E would be 0. That means if I just put the value of del cross E in this equation, it would turn out to be minus del cross E equals to minus dou by dou T del cross B. Cancelling out the negative sign, we got del cross E equals to dou by dou T and del cross B. Remembering anything that have an equation of del cross B? Well, that's Ampere's law, the fourth equation. So what I'm going to do is have putting this del cross B value over this equation. So using equation number 3, so del cross B equals to mu J plus mu J epsilon dou E by dou T. That's just a formula. To simplify myself, del cross E equals to dou by dou T, putting this value mu dot J plus mu naught epsilon naught dou E by dou T. So this value, if I just try to simplify it, and there's one more thing I like to say, okay, this thing would go to 0. This thing would go to 0 just because the J would be 0 in the, what can I say, the free space. If I just reframe and simplify it, like what can I say, multiplying dou T by dou T inside, so epsilon naught and mu naught will be outside D dot cross in E. So this equation what we got right now is a wave equation of E, that is the electric field. This is the equation that we got. Let me make it a box. That's a very long box. Okay, so this is the wave equation for electric field. And what's the generalized wave equation? Wave equation for electric field is basically written as del cross E equals to mu naught epsilon naught dou square E by dou T square. So we are marking this equation as 5th and marking this equation as 6th. What can we do is comparing equation number 5th and 6th, that is this both equation. As you can see, there's a mistake, slight mistake, that the generalized wave equation is given as del cross E equals to 1 by v squared dou cross E by dou t square. And so now comparing 4th and 5th, like we can see that everything, let me correct it, like this equation is similar to this are similar, so the only thing that changes is this thing. So when I would compare these things, and then if I just 1 by v square equals to mu naught epsilon naught, after having simplification, v is equal to 1 by this thing. So now this is the ultimate value how we can calculate the speed of light. So the value of mu naught, firstly these both things are the permeability of free space and speed, something like that. So these both things are the constants of free space. So mu naught goes by 4 pi into 10 to power minus 7 Na by A square, and epsilon naught goes by 8.854 into 10 to power minus 12 F by M. Putting those values over it, 1 by root over 4 pi into 10 to power minus 7, 8.854 into 10 to power minus 12. So calculating that thing, we got 3 into 10 to power 8, we got this value, and the unit will be decided by you. As I said, this would be written on the comment box by you guys. I'll be recorrecting and I will pin the correct answer. And let me reframe it, because it's V, actually it's C, so it 3 into 10 to power 8, that's a unit. So this is how speed of light is calculated by using Maxwell equation. So as you can see, we got the value of speed of light, neither by any experimental that I'm using right now, neither I'm doing any particular I would say research or anything. I just use 4 equation, like not 4 equation particularly. I have written 4 of this equation, 1 2 3 4, but I particularly use 3 and 4 for my calculation, knowing only two things, that after taking a curl, putting the values, getting the wave equation over here, I just put a generalized wave equation and just compare the middle term, not full terms I will compare, but everything is similar, so I will just have this two things, and after calculating those things, we got this speed of light just by using our brain equations. So this I would say proof at that time was a very groundbreaking experiment, and this is how we calculated the speed of light. So this note, either it's very messy in terms of my handwriting and everything, but I will make sure that I will put this in my description box for any of your purposes.